We're returning to that little extra package I sent to you, and we're going to talk about finishing these equations. What would these equations look like if we were to solve a graph so there's one solution? What would these equations have to look like if we were to solve them or graph them so there was no solution? And then the same question, what would these equations have to look like to get infinitely many solutions? Well, let's just do a quick review. One solution means that somewhere these two lines are going to meet. That one solution is right there. That's what it looks like on a graph. When we're solving an equation, remember, one solution means you actually can solve it and get an answer. So I'm going to go over here, for example, equals blank x plus. Really, when I'm done, I just want to be able to solve so that I can get an answer for x. Well, if I put 5 there and a 10 here, I am going to make it a 15 here. My brain was getting ahead of me. That means I would have 5x plus 15. Subtract 5 x's from both sides. Add 5 to both sides, I get 20. When I divide this out, x would equal negative 10. Because I have a solution for x, there is one solution if I were to graph this. When I do that, notice I cannot have my x's disappear. We talked about what kind of graph would have no solution. Hopefully you remember it has to be parallel lines. They will never cross, therefore there would be no solution. Well, in Chapter 5, we discussed parallel lines. What can you remember was the rule for parallel lines? They have to have something in common. So if this first equation here, if I was going to pretend, right here, that this was negative 5, up 1, right 3, up 1, right 3, what I know for this, I would need a different y-intercept, a different starting point. So I'm going to pick 6. No particular reason. I made the number up. But I also know for them to never cross, the slope needs to remain the same. If I were to solve those, I would end up over here with 3x minus 5 equals 3x plus 6. Subtract 3x from both sides, and we talk about how this doesn't work. That is not true. Therefore, there's no solutions because the x's have disappeared. Finally, infinitely many. That is when you graph one line, and when you go to graph the next line, it falls a top of it, or it is really the same line. That is infinitely many. Well, because they're the same, we have to have the exact same equation. So 3x plus, I'll call that 2, would have to be the same as the orange line, 3x plus 2. What you're going to be doing today is not actually solving math problems, but identifying by looking at the math problem, will there be one, none, or infinitely many? So for this one to be infinitely many, it has to be identical. So pause, I'll do the next ones, and then we'll pause the video. Another example of one solution, as long as the slope or the variable or the number in front of the variable is not the same, they will cross somewhere. For no solutions, I have to have the slope of my lines to be identical, so that way they're parallel, so I have no choice. That has to be a 3. But then it has to cross the y-axis at a different spot. Infinitely many, I really don't have a choice. They have to be exactly the same. Take a minute and fill in these blanks. In theory, all of us could have completely different answers, but please pause the video, fill in these blanks, and I'll talk about them. Pause the video. Thank you for pausing the video. One solution means the slopes have to be different if we were to graph them so they would cross somewhere. So as long as in this first blank you put anything but -1/2, your answer will be great. I could have put +4 there. That would be fine. That is -1/3. For no solutions, these have to be parallel lines. To be parallel, we know their slopes have to be the same, so you have to have -1/2 x in both. You may have anything here but a 4. Otherwise, it would turn into infinitely many solutions. Here are some larger squares. Take a moment, fill them in. We'll kind of talk about them or compare answers momentarily. Pause the video, please. Thank you for pausing. As we very quickly go through this, as long as the x, the coefficient in front of the variable, is different, they will have a solution somewhere. It is okay if I give them the same y-intercept. That is where they're going to meet. One time right there. No solutions. You have to catch my mistake, first of all. Oh, is that a negative? This needs to be 8. The slopes have to be identical, so they're parallel lines and they travel at the same rate. Infinitely many has to be completely identical. This is really the same as that. This is really the same as that. We could get very creative if we wanted to, and we could have done 8/4x plus 10. That would work also. If I really put 8/2, I would get 4, which is the same. That is fine.